There we go. I'm going to close email and Slack. Oh yeah, I'm recording. Welcome to the Code with Jason meetup. Tonight we're going to do some robotics programming. If you've seen a number of these, you might notice that there's a different camera angle. This is what my room looks like from not at the top of my monitor right here, but from over there on top of my printer. Tonight we're going to do some coding on this robot. So background on this project. Why am I building a robot? So every Tuesday night, I guess I should look over here, right? When I'm talking to it feels so unnatural. But every Tuesday night, me and my sons go to a chess club. We've been doing that for quite some time. We've been playing chess for a number of years. And we thought it might be neat to build a robot that plays chess. And this is a multi-layered project. One of the first things is we have to figure out how to build a robot that can move in the ways it needs to move. I've found out about something called a 6-axis robot, which is, it has what they call the base joint or the waist joint. And then it has the, it's kind of like a human arm. It has the shoulder joint, what you might call the elbow joint, which is what I have here. And then what I don't have yet is the wrist joint, which has pitch, yaw, and roll. Yeah, roll, pitch, and I confused myself. Roll, pitch, and yaw is the other way. There's 3 ways this can work. I don't know how a hand works. Anyway, we're trying to build this 6-axis robot. There's kind of a specific way to do it. And I thought the first thing I could do is get the mechanics figured out with no motorization. Just like a software project, I wanted to break it down into distinct parts and tackle each part individually. So first, I just built the mechanics of this arm without trying to involve motorization. Once I got that kind of figured out, I started hooking up motors. I have 2 motors available to me right now. So I've only motorized the base joint and the shoulder joint. Soon I ran into a problem. I got the shoulder joint going, but the robot would just spin around in a circle indefinitely, or it would spin around an arbitrary amount. But I had no way of positioning the robot in a specific direction. And I thought, well, how can I accomplish that? So naturally, I asked ChatGPT, and ChatGPT said I could add some physical barriers and make the robot move until it hit a physical barrier. And I forget what it said after that, because that was kind of enough for me to go off of. So I built these 2 physical barriers. So this robot can move one direction until it hits a barrier, because who knows where it's starting from, So it moves until it hits a barrier, and then it's at a known position. Then it does a sweep of the entire range of motion until it hits the other barrier. And in the case of the base note, the base joint, I know that that's 180 degrees. So then I can move back halfway, and I know that that's, if I call this 90 degrees and I call this 270 degrees, that's 0 degrees, pointing straight that way. Same principle with the shoulder joint, although it has less freedom of motion. That one's only 90 degrees. Okay, so with that explanation out of the way, I'm going to run my program, which calibrates the robot. Okay, so first it's doing like the throwaway sweep. It just gets to this known point. Now it's sweeping the full range of motion, so it knows how far 180 degrees is. Now it moves to the 0 degree mark. Now it's going to calibrate the shoulder joint. This is just the throwaway sweep. It's going till it hits whatever you want to call it, the 0 degree mark. And then it goes, okay, it's just doing some other stuff. But the end of the shoulder calibration is it goes straight up, and And then the movements after that are just for show. So that's what this thing does. The problem is I'm not particularly happy with the code. So let's take a look at the code and we can talk about what we might like and not like about it. Whoops. Okay. Okay. Sorry, Harry, if you're watching, I just showed your code to the world. I think you don't mind. Okay, so this is my robot program. It is all one single file because I'm using Lego Spike, and it has a development environment. Okay. So Lego Spike has kind of a frankly crappy development environment where each project can, as far as I could tell, can only have one file. And then if I click this play button here, it'll run the program on the robot. But I don't really like coding in this. I'm a Vim guy, and so I've just been coding it in here and copy pasting it from Vim into the Spike program. This allows me to do version control also, because the Spike file, it doesn't save as plain text. It saves in a weird format. Okay, so I'll walk us through here and we can talk about what we like and don't like. So here is the main part of it. And I'm going to take away this stuff at the end. I'm not sure why I even added that anyway, but here's the code that calibrates the robot. So this is easy enough to understand. Base joint equals base joint dot calibrate, shoulder joint equals shoulder joint dot calibrate. I think that's pretty easy to understand. Now you might wonder, how is shoulder joint defined and how's base joint defined? So here are shoulder joint and base joint, and we'll look in a second. There's a parent class for these two. Oh, and by the way, I don't know if I said, this is Python. So these two classes look a little bit duplicative. I haven't decided yet if they really are duplicative, because if one of these two methods changes, it's not a logical necessity that the other one should change. And remember that duplication isn't exactly duplicated code. It's when there's a single piece of behavior that's represented in more than one place. And this is not a single behavior. This is two behaviors. And in fact, this one's slightly different. I don't want to explain this detail right now, but they are a little bit different. So anyway, that's base joint and shoulder joint. Let's look at we'll look even closer at base joint and shoulder joint, but let's look at the parent class for base joint and shoulder joint. So we can move a joint a certain amount of degrees. And something I'm not happy about is we have move degrees and we have move degrees non-blocking. And that's because, oh, and it's funny, they're defined the exact same. That's because I wanted to be able to move the two motors simultaneously. And this is how I figured out to do it. But in my finagling of the program, I guess I didn't even realize that I didn't even end up making these two things different. So I think what I did here was actually pointless. So that's maybe something I don't like that much. Okay, now for the...
Can I ask just generally,
Yeah.
So it strikes me that you're trying to think of ways to make this code clean and organized and uh, have a very good interface. But at the same time, you're sort of learning the system and experimenting,
Mm-hmm.
which to me, the approach that I would take at first would be to write a whole bunch of code that I would then throw away as I'm learning the system, because I'm not sure how to parse things up yet in terms of classes when I'm not really sure how the machine works yet. And until I get a better sense of how the machine works, I can't start to organize what should be, base classes and then extend from there and start to really make the code clean.
Yeah, I think that's a really good point. Um, I have done that to an extent, and I'm continuing to do that in certain ways. Um, what has also happened in the course of my doing that is I have desperately confused myself. And so when I get to those points where I can no longer understand what I've done, I'm using that pain to guide my refactorings. I guess I should also say that right now I'm kind of making an appraisal of the code and pointing out things I don't like. Um, doesn't necessarily mean I intend for us to address all those things right now. But I do agree with your way of thinking about that, Nelson. Okay. So I have this concept called a sweep. And by the way, if you guys like see any of this terminology and you're like, what does that mean? Please let me know, because you guys have the benefit of not being familiar with this code. And so if you see things and they're not self-evident, you're in a position that I'm not in, where you can look at this with fresh eyes and say, hey, that's confusing. So if you see something that's confusing, please point it out, because that helps me. Okay. So first I do this discard sweep, and that could maybe benefit from a better name if I could think of one. But this discard sweep is done because we don't know the starting position of the robot. We don't know the starting angle. And so we need to get to a known position. So that first sweep, since we don't know how far it is, that needs to just get thrown away because it's useless information. I don't know if I'm doing a good job of explaining that part though. Um, how much sense is this discard sweep idea making to you guys? Hmm. I don't know whether to interpret your silence as you understand or you don't understand. Jonathan, what do you think?
I just went AFK for the last 4 minutes.
Oh, okay. Well, never mind. Helmet, what do you think? Oh, sorry. I think you're muted, Helmet.
I was partially trying to follow discard sweep and also sort of trying to figure out Python syntax.
Okay.
Um, yeah, so I really don't have any understanding of discard sweep.
Okay. Yeah, maybe let's talk
So
about this then.
I'm
Yeah.
confused as to whether, so does this apply to like a single motor where you're moving the motor all the way to one side to try to find like the some end position to
Hmm.
the arm or the joint? Or is this something else where it's like, no, no, it's not just one motor, it's the whole system?
Yeah, good question. Um, And I don't even know how to answer that. And I think the best way for me to answer that will be for us to change the code so that that answer is so that question is fully answered in the code. Okay, so I want to pause for a second and make what I think is an important point. So, and it's great that we have this physical thing, because this really helps make the illustration easy. We have this physical thing that exists. It's a robot. It has motors. It has an arm, and it has joints. These are real tangible things that we can actually look at and touch. And then we have the code. And the code is made out of names of things. That's like, in a sense, that's all code is like a bunch of names of things. But then we have this third ethereal thing that I refer to as the conceptual model of the program. So this variable name is discard sweep, but it's more than just a variable name. It's a concept. Like, when we're calibrating this robot, I came up with this kind of arbitrary concept of a discard sweep. It's not anything anybody besides me ever thought about. I mean, maybe somebody landed on the same idea, probably, but this is like an invented concept. And this concept is represented in the code, but like, that's not where the concept originated. The concept just originated, in my mind, I guess. And every program has that thing. There's like the real world concepts, and there's the code, but then there's this third thing, this conceptual model that only exists in the minds of all the people who use and think about the system. And the conceptual model is like kind of the most important thing. And if you have a muddy or confused conceptual model, or if you haven't thought out the conceptual model very clearly, your code is going to suffer, because your code is downstream of the conceptual model. This isn't Ruby, I'm out. Okay, for a second I thought you really left, Travis. Okay, so let's get some more clarity on this discard sweep idea. And this is kind of like one little detail to focus on, but I think that's fine. So Nelson, since you asked the question about it, maybe let's you and me talk about this a second. Can you restate your question for me?
Yeah, so when you're saying there's a discard sweep, I'm assuming that you're trying to get at some baseline by discarding a lot of information, or resetting a motor, or resetting your state in some way. But I'm not sure what that thing you're resetting is. If it's like a motor, or if it's like the arrangement of two different things, or if you're like, if you have a camera and the camera is trying to find something, or if you have a notch on the motor that tells it, oh, this is the stopping point for this motor, or if it's something else entirely.
I'm so glad that you're bringing this up, because it never even occurred to me that those questions could it never occurred to me that I needed to think about those things, because everything's so obvious to me, because I've been working so closely with this. But you saying that makes it clear to me that those things need to be clear. So I'm going to illustrate, at least partly, by showing you. So I'm going to, again, take out all this stuff, and I'm going to make it so we're only doing the base joint calibration. And we're actually only going to do the first part. We're only going to do the discard sweep. Okay, I'm actually going to grab my camera and hold it over the robot so we can see the angle very clearly. Okay. So I want to make it so this is the top. Yeah, okay. Yeah. Okay. So the top, the front of the robot is pointed at the top of the screen. So this is the back, this is the front. Right now, the base joint is pointed a little bit to the side. It's pointed like this way. Oh, you can't see my arm. If you can see my hand, the base joint is pointed like this way. It's not pointed at 0 degrees, which I'm deciding is this way. It's pointed a little to the left. And the thing is, when this robot finishes a session of usage or whatever, we don't know where it's going to end up. And so our program doesn't have any way of telling where the robot is starting out. And so what we have to do, and I'm going to start the program now. What we have to do, okay, there it stopped. Sorry, this is hard to hold the camera in a way that this is disoriented. There we go. Okay. Now the motor, the arm is pointed straight this way. Before it was pointed this way, now it's pointed this way. And the reason why it's pointed this way is because it hit a physical barrier. This right here. So this is the arm, and this part of the arm hit this physical barrier. And when this part of the arm hits this barrier, I designed it so that is exactly 90 degrees. Okay. But what just happened was a sweep of the arm of an unknown distance. We don't know where the arm started in terms of how many degrees it was. All we know is that we ended up at the 90-degree mark. So now we do the second sweep. It goes from the 90-degree mark, 180 degrees over to the other side for, it goes from 90 degrees, crosses 0, and goes around to 270. And when it goes from the 90-degree mark around to the 270-degree mark, it knows it has made a sweep of 180 degrees. And it measures how many turns the motor has turned. And it says, okay, like 8.5 turns of the motor, or whatever it may be, 8.5 turns of the motor equals 180 degrees. And that's how, from that point on, we can know how much to turn the motor to get it to however many degrees we want. Okay, so that was my attempt at explaining why we need 2 sweeps. We need this like throwaway sweep just to get us to the 90-degree mark. And then we do the real sweep that we actually measure, that measures how far 180 degrees is. All right, I'm going to set my camera down and let's talk about this some more. Okay. And if you guys didn't understand all the stuff I just said, that's not your fault. That is my fault. So Nelson, I'll ask you first. Did that shed any light on things?
Yeah, it did. But I'm still a little, I mean, I don't know anything about robotics, but I do know that when you apply electricity to a motor, it sort of it more or less keeps going until the force some other force, some stronger force. In this case, the barrier exerts itself. Is
Mhm.
that what's happening, or does it know some other way that it stopped moving? Like, is there another sensor involved, or
Yeah,
is it
good
just
question.
that the motor stopped turning?
So these are servo motors, which means in addition to saying like start running and then stop running, you can say, for example, rotate this motor 180 degrees, 360 degrees, whatever you want. And in fact, if you look up here in the upper left, you see motors A and C. And you see A is at the 70-degree position and C is at it's oscillating between 131 and 132. So I'm going by little bits at a time. And let me demonstrate this once more. Okay, so my discard sweep this time, since we're already at 90 degrees, my discard sweep is going to basically be a no op. It's going to say, okay, I'm already stuck. So now it starts going the other direction. And you can see it's not a steady movement. It's going in little jerks. And then same thing with this other joint. It's not a single steady movement. It's going in little bits. And then when it gets stuck, it will go in a single movement up to the top. So the reason it's going in those little jerks is because I told it that it should go 50 degrees at a time. So each one of those little jerks is the motor turning 50 degrees. And actually, let me do this. Okay, so I'm going to run this again. You can see that the motor is just going a little bit at a time. Now it got stuck. Now it's going in the other direction. Then it's going to center the joint. And now this other motor is going 50 degrees at a time. And the reason I did it in these little jerks and not one big motion, my logic was this. I'm measuring the amount moved after each step. That's actually the term I'm using. I'm measuring the amount moved after each step, and I'm kind of keeping a running total. And at some point, it's going to get stuck and it can't move any more steps. And so, however many steps it moved before it got stuck, I sum up the distance for all those steps, and that's the total distance. Whereas if I had just done, well, if I had, for example, done bigger steps instead of 50 degrees, if it was 100 degrees or something like that, the measurement would be a lot lower resolution. And so it would be a lot less precise. That was my reasoning, at least. Okay, I'm going to set my camera back down again. One thing I'm definitely realizing from this is that there are a lot of things that seemed obvious to me that are very much not obvious. So, how can we make all of this clear? And I guess a distinction should be made. the code has a certain level of responsibility. The code has a responsibility to explain itself, but it of course doesn't have a responsibility to explain the world to you. And so some things can be robotics concepts, and it's not the code's job to explain that. But anything that's like peculiar to this program, I think it is this code's responsibility to explain. And right now, I kind of think it doesn't do a very good job of explaining it.
One place that I think would make a big improvement is you spend a fair bit of time talking about the discard sweep.
Mm-hmm.
I wonder if you just renamed it. I don't know if there's a more appropriate term, but like sweeping to minimum, and then your second sweep will be sweep to maximum.
Yeah.
Something along those lines.
Okay, let's think about that.
I did
Yeah.
stick an alternative term in chat. I don't know if you have chat open or not, but in the automation and robotics world, the common term there, I think, is homing to get to a known state before you calibrate.
Oh, okay.
Not sure if that means anything to a developer necessarily, but going with ubiquitous language can be a positive thing sometimes.
Yeah, Helmet says get to zero sweep. Okay. Well, the thing about homing, so I like that, but the thing about it is these two physical blockers, neither one is like kind of a home position. They're like the extreme left and extreme right. Let me think for a second. If you're looking at a circle, and okay, if you're looking at a clock and you go to the 3 o'clock position, that's 90 degrees, right? And then if you go to the 9 o'clock position, that's 270 degrees. Is that right?
Mhm.
Okay. Yeah, because like one blocker is at the 9 o'clock position. The other blocker is at the, sorry, I always get this backwards. One blocker is at the 270 degree position. The other blocker is at the 90 degree position. And so I'm going counterclockwise to the 270 degree blocker. Then I'm sweeping clockwise to the 90 degree marker. Maybe it'd be more logical the other way around. I go clockwise to the 90 degree marker, then I go counterclockwise to the 270 degree marker. Anyway, that first sweep is intended to get to the 90 degree blocker. What if we do this? Get to 90 degree blocker. Like that's just saying literally what is happening. That's a tactic I use sometimes when I can't think of a name. I just like say literally what it is, even if it sounds really dumb. And then of course I would have to move this to here and say self.get to 90 degree blocker.
One possible pitfall there is you have an implementation detail in your variable name. They're pretty easy to rename in a file this size, but if you get a really large project, that might become less manageable. So maybe get to bounding blocker or something like that. That's a little bit more generic, but still conveys meaning.
Yeah. So I was aware of that shortcoming of this name. It is, you might say, inappropriately concrete. But I didn't feel like I could afford to bring more abstraction into the picture, because if I start to try to make it more abstract, it's like, okay, how do I name it? That makes it too hard. So first I'm going to give it, here's my plan anyway. I'm going to give it names that are super, super explicit and clear, even if they're inappropriately concrete. And then once I see all that laid out before me, maybe I can take those concrete parts that contain incidental details and abstract those parts away. Get to starting blocker. Maybe I like that. Okay, and I also have to change the direction in which we're going to go. So instead of going 50 degrees, I'm going to go negative 50 degrees. So 50 degrees would have been counterclockwise. I'm going to go 50 degrees, so it's clockwise. Okay. And I think I need to switch this also. Okay, let's see if I manage to do all that without any mistakes. Okay, it is going clockwise. It's getting stuck at the blocker. It's going counterclockwise. Stuck at the blocker. Ugh. Okay, no. Okay, that didn't do what it was supposed to do. And if I had let it keep doing this, it would kind of rip itself apart. It's a mechanical flaw. Okay, so I had changed the sign of this number here from negative 90 to 90. Oh, whoops. Did I? Hang on. Shoulder joint. I wasn't changing what I thought I was changing. Okay. Well, that explains that. Yeah, thanks. I've had a lot of fun with this. Okay. So I'm going to change that. Get to 90-degree blocker. Then I'm going to change this. Then I'm going to say await self dot get to 90-degree blocker. Okay. Let's see how we do with that one. This will be interesting to see how it behaves now that that arm is not in the normal position. Okay, it's stuck. No, that's not what's supposed to happen. Okay, I'm just going to run it again unmodified because sometimes it just behaves wrong for mechanical reasons. Okay, it got stuck and made that awful noise. Now it's doing what I would expect. But wait, it went counterclockwise initially, right? Oh, now, okay. Things are going way wrong. So I'm going to undo to the point where things are going right again, because rather than figuring out what the problem is, it's usually cheaper just to go back to a known working state and try again. All right, so I'm going to paste this back in here and rerun it. It's doing the shoulder joint first. Yeah, I don't know. Okay. All right, I don't know how I managed to make it do that, but I want to do the base joint first, not the shoulder joint. So that is now fixed. Okay. Okay, great. Now it's doing the base joint in the way that I would expect. Get stuck. Stuck again. Now does it move to 0? It does. Now it's calibrating the shoulder joint. Okay, and the main thing I wanted to see was the base joint. So I'm going to commit the way it is right now because this is working. Okay, now can I make the very small change of adding get to 90-degree blocker? Put this in here and call await. Oh, I see. No, I don't see. Never mind. Okay. That seems like it should work. Let's see if it really does. And this is why I want to add some automated tests to this so that I don't have to wait for the physical tests every single time. Okay, that worked. So now let's change it from initially going counterclockwise to initially going clockwise. Oh, wait, sorry. I think that's not going to work because we have this, when it centers itself, when it moves 90 degrees, I think it needs to go the opposite direction it was going, so negative 90 degrees. Okay, it's going clockwise, getting stuck. Counterclockwise for the full sweep. And then after it gets stuck, it should go to the 0-degree position. And it does. Okay. Great. So I'm going to commit that. Okay. So add get to 90-degree blocker method. Okay. And now we can do something like get to 270-degree blocker. Okay. Let's see if that behaves as intended.
You didn't grab that sweep, I don't think. So you can't get the range from it.
Good catch. Okay. Okay, so far so good. Okay, great. Okay, so I'm going to commit this. Okay, we added get to 270-degree blocker. Okay, and now I feel like I have an idea of how to improve this. Um, maybe. Okay. So maybe we can say something like this.
It kind of
Well,
bugs me that you have two functions that are kind of named the same, but one's return. Like I'd be kind of expecting that get 270 to not return the range. Like it's getting it's going the distance and setting the range.
right, it's a side effect. It's
Yes.
it's surprising that it does that, and that's bad. What I think I want something like this. I want something like self.range equals measured distance to 270-degree blocker, something like that. And then, of course, the range assignment doesn't happen inside the function. Even before that, oh, never mind. No. Okay. I'm going to ask ChatGPT about this one because I don't know how it works with all the asyncs and await and stuff like that. That's all new to me. How can I make it so I can do something like self.range equals get to 270-degree blocker? Yeah, specifically what I don't know is I don't know how to use a return value with await. Oh, just like that, apparently. Okay. Okay, self.range equals blah, blah, blah. And then here, I assume I can do that. Let's try that. Okay. The fact that it successfully got to the 0-degree position tells me that that range assignment worked. So we can commit that. Okay. So I like to think about the APIs of a program kind of from the highest level to the lowest level. So at the very highest level, we have base joint.calibrate and shoulder joint.calibrate. That's all fine. I feel good about that. Then once you go down one level to the definition of base joint.calibrate, I'm less happy with this. Get to 90-degree blocker, self.range equals get to 270-degree blocker, and then move degrees 90. I'm actually going to focus on this for a second, move degrees 90, because like, why? Why are we doing this? We should maybe say like, well, for the moment, we can at least say await self dot move to 0-degree mark.
I wonder this would be a good place to introduce the vocabulary that Eric had suggested. saying like get to home.
Yeah. I will circle back immediately and do that. But let me get this working. Okay, move to 0 degree mark. Okay. Yes. Okay, I already made a mistake. Let's see where.
Colon
Oh.
on 97.
I forgot Python's stupid thing where you have to put self in all your methods.
I think you're missing a colon on there too.
Oh, really? Yeah, thanks. Okay. Okay, so home. Do I feel like we call that the home position? If it weren't called the home position, what would it be called? I guess home is good. For some reason, I feel less than 100% comfortable with the name home, but I can't think of anything better. Okay, so I'll say move to home position. Okay, and then I will run that. And if that succeeds, I'll commit what I have here. Move to home position. I hate that sound. Oh, for some reason it took a long time to do it, but it did work. Okay. Okay, and I see that it is 10 o'clock, so I'll try to wrap it up soon. Okay, so now what can we do about get to 90 degree blocker and get to 270 degree blocker? Let me think. What's the significance of these blockers? It's like these blockers restrict the range of motion. Maybe these blockers are restrictors. Maybe they're the clockwise restrictor and the counterclockwise restrictor. Maybe they're the counterclockwise bound and the counterclockwise bound. Does anybody have any
Constraint might be another word to use.
constraint? Counterclockwise constraint?
Bound sounds more abstract. I don't like that as much as constraint or restrictor,
Okay.
personally.
Restrictor. Counterclockwise no, not constrictor. It's not a snake.
Right.
Clockwise restrictor.
You've you've kind of fumbled a little bit over degrees and is it counterclockwise or clockwise and stuff like that. I almost would like to not hear degrees and clock words. Like maybe like start or end of range or something like that, but like yeah, especially when you have, especially like when you start going with 90 and 270, like what happens if you wrap around to 180? You have to like blow through the blocks for that to happen. I'm a little bit uneasy with the degrees and the clockwise words.
Can understand that. Yeah, it's like the fact that it happens to be a 180 degree range of motion is an incidental detail. the significant thing is that it has a limited range of motion. These are like range limiters or something like that. Are they? Are they range limiters? And could you call them a minimum and maximum? Like a floor and a ceiling? Oh, that's directionally problematic. um range of movement limiters. What do you guys think about this range limiter concept? Physical range limiter. Let's see, we move until we hit one physical range limiter. And then we move until we hit the other physical range limiter. Sweep range limiter. Well, it's the sweep is just a calibration movement, and the range limiters still have a job beyond that calibration stage. Rotation range limiter. Interesting. Rotation range limiter. Rotation range limiter. I think I like that. Okay. And what's the distinction between these two rotation range limiters? Are they the minimum rotation range limiter and the maximum rotation range limiter?
That might get a little bit confusing because it kind of has like a left-right association with it or something. I wonder if you're going to get confused if you start thinking about the degrees. So like, is the minimum 90 and the maximum 270, or is it vice versa? I wonder if start and end doesn't give like a scale to it. Yeah, or beginning and end.
Yeah, and maybe I should really be referring to 270 as negative 90 for clarity. But that's kind of a side note. Yeah, beginning and end, lower and upper.
I'd also be probably thinking a little bit because when you get to the other joints, you're going to have up and down. So start and end, beginning and end still applies.
Yeah, that's a good point. Okay, let's try it on for size. Instead of saying get to, I'm going to say move to. Move to beginning. What did you call it, Helmet?
Rotation range limiter.
Rotation range limiter. Rotation range limiter. I'm going to use beginning instead of start because beginning can only be a noun, but start can also be a verb, which can be confusing. Move to beginning rotation range limiter. Okay. And then we can say move to end rotation range limiter. Okay. Okay. Let's just see if this works. Okay, and while that's doing its thing, we can look at the code and maybe see how we feel about it. Okay, so that worked. Okay, how does base joint.calibrate work? Well, first we move to beginning rotation range limiter. And then the range is we move to the end rotation range limiter. Then we move to the home position. It seems like for consistency, we should call it rotation range. But first, I'm going to commit this.
I wondered if we even needed limiter in the beginning range limiter and end range, end rotation range limiter. I didn't know if we needed limiter. Just it's a range.
Yeah, we move to the beginning of the rotation range, and then we move to the end of the rotation range. And who cares how? The fact that that happens via a physical blocker is just an implementation detail, it could be argued. Okay, let's do that. Move to beginning of rotation range. Okay, move to end of rotation range. Okay. Okay. And then, I don't know if this is going to be a popular change, but I'm going to say move to middle of rotation range.
Pretty clear.
I think so. Okay, let's see if that actually works. And by the next video, I'll make this structure a little more rigid so the gears don't slip and make that awful noise. Can you guys even hear that?
Not at all.
Consider yourselves lucky. I cringe every time I hear it.
That mic is pretty good at limiting the environmental noise.
It seems so, yeah. Okay. Okay, so how does the calibration happen? We move to beginning of rotation range, move to end of rotation range, move to middle of rotation range, and that is the end of the calibration.
Can I make a suggestion?
Yeah.
I'd kind of like the calibrate to say something like self.range equals await self.get range.
Yeah.
That new get range function would do the move to beginning, move to end, and would return the range from that last sweep. And then I would make the move to beginning and move to end. Both of those return that awaited sweep. So you'd have that consistency between those two move to beginning and the move to end.
Okay. You might have to repeat some of that, but let me catch up.
So in there, yeah, I would say so in there I'd be wanting to return, so that I would have that be range equals await self.move to end, and then return the total degrees after that. So I wouldn't actually, that range won't actually return okay, sorry. So I would, on line 97, I'd return the sweep there, and then remove line 98. And then on line 89,
I see.
I would get the range equals await self.move to end, and then return the total degrees from that there.
Yeah. I'm smelling what you're stepping in. Let me run this and make sure it actually still works. And then I'll do that other change. Didn't even compile. Okay. Line 84. Could it be that Python doesn't like it when you have you know, that thing that I just did with the two things having the same name? I'm getting less articulate as the night goes on. Okay, apparently that was in fact the issue. Okay. Okay, yeah, and so now, that noise. Okay. Now we return the sweep. I got to change these sweep names too, I think. Okay. Move to, yeah, okay. Something like that, Jonathan?
Yeah, I'm not sure how the await's gonna mix in with that. I've never used it with Python, so it might yell at you, or it might need parentheses or something, but we'll
Yeah,
see.
I have no idea. All right, see you later, Helmet. Okay, let's see how that does. Okay, we did in fact get an error, line 89. And the errors tend to be not very helpful. Generator object has no attribute total degrees. Oh,
I
I'm
wonder if you
not
have to
return.
put.
What's that?
I wonder if on 89, if you have to put a brackets, a parenthesis before await and before the total degrees. I wonder if it's awaiting the whole entire thing as opposed to awaiting.
Well, let's try this.
Yep. I bet you that works.
I bet you're right. Yep. Okay, another message in the chat. All right. Thanks for coming, Nelson. Talk to you later.
I don't know if this is useful, but I probably would throw in a return on the sweep that's in the move to beginning. Just have consistency.
Oh, interesting. All right, let me catch up, Jonathan. I'm a little bit behind. So we're doing self.range equals get range, move to middle of rotation range. Okay. And get range, we move to the beginning of the range, and then we move to the end of the range. And yeah, we
I wonder if
Okay.
you're just renaming that to be a full sweep.
I don't know. So it's like, is it a move or is it a sweep? Or is it something else? That's the discomfort I'm feeling right now. But I don't know if I even want to go so far as to resolve that tonight still. Beginning of rotation range, we do that. Okay, so these names are a little bit weird now. Like, what's discard sweep at this point? So I'm gonna do like that. And here I think I can just do this. Okay. Let's see if that works. And if that works, I think I'm happy with just leaving it there for tonight, even though there's obviously quite a bit more we can do. Okay, great. Okay. It's a good 20 minutes. No, not a good. It's a good 19 minutes over. And I'm about out of juice anyway. So I say let's leave it here for tonight and pick it up next time. But I definitely think we made an improvement. This seems better to me. Like there's none of this discard sweep business. Move to beginning of range and end of range. That seems much clearer to me. All right. Well, thanks everybody for joining, and I'll see you next time for more adventures in robotics. Goodbye.
Take care.